So I want to go through one of the exercises in the book, and then I would like you to come up with your own version of this and submit it. So this is in section 6.2. It's number 4. I've changed the numbers. So pretend like this is a wedge. And then you'll notice I have it set up in 3 dimensions. So x, y, z. It does follow the right-hand rule for my physics and chemistry folks. So I'm going out 2 in the x, out 3 in the y, up 4 in the z, and then I just have a plain old wedge. Okay. So what we're going to do is we're going to slice it and add them up. So we're going to use that idea of finding the area, multiplying it by the volume, and adding up all of those little volume slices. So first of all, we're going to cut it perpendicular to the x-axis. So let's imagine what that cross-section is going to look like. So here's my x-axis. So if I slice down perpendicular to that, the shapes that we're going to get are going to be little rectangles, right? So I need the area of the rectangle and then my thickness, is that little dx. And my x's go between 0 and 2. So those will be my limits of integration. Okay, so now let's think about how we would write the area of that rectangle. So length times width, right? And so the length, the nice thing about rectangles, it's, well, in this case, the y is always the same, right? It's a constant y of 3 no matter where you draw that rectangle. The y value is 3. So my width is going to be 3. Now my length, or the height maybe, so this dimension here, that does change depending on where we are, where we draw that rectangle. So somehow I have to get that height, which is the z value, but I need it in terms of x. The 3, it didn't matter because it was a constant, but the height, it depends. So here's how we're going to do it. I'm going to go ahead and just grab out the z and the x-axes. And I'm going to, so 4 is where it crosses on the z, and 2 is where it crosses on the x. And it's a straight line, a nice diagonal line. So I think we could find the equation of that line. So I know my z-intercept is 4. So z equals the slope, so it's negative, and it's change in this case z, vertical direction, over change in x, times x, plus your z-intercept. So z equals negative 2x plus 4, and that is the height of each of the rectangles, because it changes. So for this length, height, whatever, I'm going to put in negative 2x plus 4. I guess I started off with the most challenging one. That's okay. So 0 to 2, my area is 3 times negative 2x plus 4 dx. The 3 can come out. Negative 2x plus 4. Remember, the 4 can't come out because it's not a multiplier. It's an actual term, and it has an antiderivative in there that we need to find. So here we go, antiderivative, 3 times negative 2x squared over 2 plus 4x between 0 and 2. Cancel those guys. So 3 times, what do I have? Opposite of 4, opposite of 4, and then plus 4 times 2. That was 2 squared is where that negative 4 came in. So I have 3 times negative 4 plus 8 is 12. All right, so now let's see if we get the same thing, hopefully, if we cut perpendicular to the y-axis. Okay, so let's think about so here's my y-axis, so if I cut those wedges, oh, my 3-dimensional drawing is just scary, It looks like a little triangular wedge. So now, I'm going to integrate the area of the triangle. And then I have a little dy, that's my thickness. And my y's go from 0 to 3. So then area of a triangle, right? Just in general, right? 1/2 base times height. So the base is the x value. And if you look for all of those triangles, the x value stays the same. Okay, so my base is just going to be the x value, which is 2, right? It's a constant. And the height for all of those triangles is the z value, which is also a constant, right? For each of those triangles that would draw going along there, the height is the z value, which stays constant at 4. Oh, okay, so 0 to 3, 1/2 times 2 times 4 dy. So we're just integrating 4 dy. So 4y between 0 and 3, also 12. Oh, that was much easier. Okay, finally, if we cut perpendicular to the z-axis, okay, so now we're going to have, it looks like rectangles again. Okay. And so area of a rectangle. And then dz, and z's go between 0 and 4. So then the area of the rectangle, length times width. So let's see, all of those rectangles have the same, is anything constant for them? Looks like the y value stays the constant, right? So I'll have a constant y value. So we'll call that one the width, and the y value stays constant at 3. But this part here, right, the x part is going to change. So the length is going to be the x value. So I have 0 to 4 of 3x dz. Okay, so this, I need this x in terms of z. Oh, we did that already, didn't we? I know that z equals negative 2x plus 4. So x is, what do I get there? 2x equals 4 minus z. So x equals 2 minus z over 2. So I can just use that to plug in. So 0 to 4, 3 comes out front. 2 minus z over 2 dz. 3 times 2z minus z squared over 4 between 0 and 4. So I'll get 3 times 8 minus 16/4. The 0 again, everybody has a z. So that's again 3 times 4. Hey, 12. All 3 ways.